Hi, my name is Lorenza from grade 11 science. Today I'm going to explain my physics project. So the learning objective is first to construct circuits using FAT simulation. Second, to compare parallel and series circuit. Third, to measure voltage and current in parallel and series circuit. So first we open the link. And the second instruction is to measure the EMF of one battery. One battery, gonna measure. So the black one is negative, the red one is positive. This part is positive, and gonna attach them like this. So the voltage of one battery is 9 volt. Next, we need to construct this circuit as I already construct here. The next is to measure the potential difference in each resistors using the voltmeter. To measure the voltage in each resistor, we need to connect the positive to the positive and the negative to the negative. If you do it positive to negative and negative to positive, as you can see, the voltage here is negative, so this is wrong. So we need to switch it like this. Now the voltage is positive, so this one is 3.37 volt. Next one, wrong, so negative, like this, switch 1.12 volts. This one 1.13 volt. This one is 2.25 volt. This is negative, so this is the wrong side. Switch. This one is 3.38 volt. So now the next step is to measure the current in each component using the ammeter. Connect the ammeter series to each of the component. So as it says, series to the component. So we take the ammeter, we connect them here. Need to make it more bigger. Okay. Now we just need to do it with all of them. Copy. Copy. Put it here. Like that. Get another ammeter. Okay. Connect. Connect. One cut. Ammeter. Let's put one for the battery too. As you can see, and in a series circuit for the current, I1 equals to I2 equals to I3, while in parallel, I1 equals to I2 plus I3. So this one is in a series, so 0.11 ampere plus 0.11 ampere, which equals to 0.22 ampere. And this series is parallel to this one. So I1 equals to I2 equals to I3. Oh no, I1 equals to I2 plus I3. So I1 equals to I2 plus I3, which 0.22 ampere equals to 0.11 ampere plus 0.11 ampere. So the next step is to explain the flow of the electrons and conventional. As you can see here, this is the electrons. Electrons flows from the negative all the way to the positive. While conventional, they flow from the positive all the way to the negative. Now we need to construct this circuit using two batteries. So now we have constructed the circuit. Repeat step number 5 and 6. So we need to measure the potential difference and the current again. So first, this one, the battery is 18 volt because 9 times 2 is 18. Next, we measure this one, 9 volt, also 9 volt. This is also 9 volt. This is also 9 volt. So in series, voltage across the circuit, the total voltage across the circuit is equal to the total voltage of the battery. Since this is 9, so this is the total is 18, right? Meanwhile, in parallel circuit, the voltage is equal across all the component. So since this one is 9 volt, so the other one is also 9 volt, and same goes to this one. So this is 9 volt and 9 volt, 18 volt, the total voltage. So next we need to measure the ampere using ammeter. Remember to connect it series to the component. Start with here. Gosh, okay. The battery is 1.8 ampere. Now we put here 0.9. So put one here, also 0.9. Here, put another here, also 0.9. Wait, let me fix. Oh no. Yeah, okay, like that. Also 0.9. Put another one here. Also 0.9. So in parallel circuits, the current is I1 equals to I2 plus I3. So this is I1, this is I2 plus I3. 0.9 plus 0.9 equals to 1.8. Same goes to this. So the next step is to click value to answer these questions below. Click values. So now to answer the questions, state the parallel and series circuits difference. In potential difference in series, V1 equals to V2 plus V3, while in parallel, V1 equals to V2 equals to V3. For current in series, I1 equals to I2 equal to I3, while in parallel, I1 equals to I2 plus I3. For the total resistance, in series, R1 equals to R2 equals to R3 because series circuits only go in one path. So the resistance, they don't split. While in parallel circuits, the total resistance is 1 over R2 plus 1 over R3. Then the answer, you would flip it. So if the total is 1 over 5, so the resistance would be 5. In parallel circuits, they have more than one path. So the resistance, they split. The next question. Diagram shows a circuit containing two resistors of resistance 1 ohm and 2 ohm. A voltmeter is connected across the 1 ohm resistor by connecting P to X. The reading on the voltmeter is 6 volts. This is the picture. P is moved to point Y in the circuit. P is moved to point Y in the circuit. What is the new reading on the voltmeter? So since this is in a series circuit, we just add this 1 ohm plus 2 ohm equals 3 ohm. While the P is attached to the point X, it says that the reading on the voltmeter is 6 volts. So now when you move the P to the Y, we just calculate like this. 1 ohm over 6 ohm, 1 ohm over 6 volt equals to 3 ohm over X. Since we're calculating for the new volt. After the calculation, you would find the volt is 18. So after you move point P from X to Y, the reading on the voltmeter is 18 volt. Now, question 3, data based on the figure from figure 1 and 2 constructed, calculate A, potential difference in each of the component, B, current in each of the component, C, total resistance of the circuit. For figure 1, The battery is 9 volt, resistor 3.37 volt, 3.38 volt. This is 2.25 volt, 1.12 volt, 1.13 volt. The current is 0.34 ampere, 0.34 ampere, 0.34 ampere, 0.2 ampere, 22 ampere, 0.11 ampere, 0.11 ampere. Now the total resistance. To calculate first, this 2 is in a series, so add it up. 10 plus 10 equals to 20 ohm. Now, this 3, they are in a parallel, so 1 over 10 plus 1 over 20 from the earlier we calculated equals to 3 over 20. Then the resistance would be 20 over 3 ohm, which is 6.67 ohm. Now, these two are in a series together with the one we just calculated. So 10 plus 10 plus 6.67 ohm equals to 26.67 ohm. For figure 2, the battery is 2, so 18 volts. This is 9 volt, 9 volt, 9 volt, and 9 volt. Since they are in a parallel, so they are the same. For the current, 1.8 ampere, 0.9 ampere, 0.9 ampere, 0.9 ampere, 0.9 ampere. From the question number 1, we already answered. For the current in parallel circuits, I1 equals to I2 plus I3. So I1 equals to I2 plus I3. So 0.9 plus 0.9 equals to 1.8. Same goes to this one. For the last one, calculate the total resistance. So this is 10 ohm, 10 ohm, 10 ohm, 10 ohm. For the parallel, R total equals to 1 over R1 plus 1 over R2. So 1 over 10 plus 1 over 10 equals to 1 over 5. So the resistance is 5 ohm. Since there is 2 the same, calculate another one and add them up. So 5 plus 5 equals to 10 ohm. So that's my project. So that's my physics projects. Thank you for watching.